And then finally, I wanted to make you guys this aerobic respiration summary chart because sometimes a lot of detail is super overwhelming and you just want to know like what you need to know. I understand that. So here we go. Okay, where in the cell does glycolysis happen? It happens in the cytoplasm. What is the situation with the carbons? We are starting with 1 6-carbon glucose, and we are going to 2 3-carbon pyruvate. What is happening with the electron carriers? 2 NADH are made. I don't know, I want you guys to be able to see, but let me switch to a fat Sharpie. Hold, please. Okay, is any ATP made? Yes, 2 ATP are used, 4 ATP are made, so that leaves us with 2 net ATP. Is oxygen used? Not used. Alrighty, on to pyruvate oxidation. Where in the cell does pyruvate oxidation happen? It happens in the mitochondrion, in the intermembrane space. Maybe the little one would have been better after all. Too late, I've already committed. So pyruvate oxidation happens in the intermembrane space of the mitochondrion. What's happening with the carbons? We go from the 2 3-carbon pyruvate to 2 2-carbon acetyl-CoA and 2 1-carbon CO2. Electron carriers is 2 NADH made. There's no ATP made or used, and no oxygen is involved in pyruvate oxidation. The oxidation refers to the losing of electrons, not the presence of oxygen. True facts. Okay, so the Krebs cycle, where is it happening? It is happening in the mitochondrial matrix. What's going on with the carbons? Our 2 2-carbon acetyl-CoA is going to 4, because 2 times 2 carbons is 4, is going to 4 CO2s. We run the Krebs cycle twice, so this is going to be total values. Total values is 6 NADH made, 2 FADH2 made, 2 ATP made. Again, these are total values per glucose. Oxygen is not involved in the Krebs cycle. The electron transport chain happens in the inner membrane of the mitochondrion. It has nothing to do with the carbons because we have turned them all into CO2 already and breathed them out. All of the NADH and FADH2 that we have made are used. And so here's what you do. You go through and you say, hang on, let me pick pink. I'll pick pink. Okay, so we go back to this summary chart thingy that Dr. Knight will want you guys to know. So cytoplasmic NADHs are worth 2 ATPs each, so 2 NADHs times 2 ATPs is 4 ATPs. Mitochondrial NADHs are worth 3 ATPs each. So this happened in the mitochondrion, so 2 NADH times 3 ATPs is going to be 6 ATPs powered by that. These 6 NADHs at 3 ATP each are going to make 18 ATP. These 2 FADH2 at 2 ATPs each are going to make 4 ATP. And so what you do is you add up this 4 ATP plus that 6 plus that 18 plus that 4, and I don't know about you guys, but I would turn that into the 8, and then I would just have 18 plus 14, which is going to be 12, carry the 1. So that's going to be 32 ATPs that we have made by taking the NADH and the FADH2, releasing their electrons, using the protons, which then goes through, you can't see that, sorry, which then goes through the ATP synthase. So in electron transport, we make 32 ATPs. If you follow this conversion system, we make 32 ATPs as a result of the electrons being put into the electron transport system, which powers the pumping out of the protons, and then they come back in through ATP synthase, and we make the ATP. When we combine that with the 4 ATP from here, okay, so we've got the 2 net ATP from glycolysis plus the 2 ATP from the Krebs cycle, then the 32 ATP plus the 4 ATP is going to give us an approximate 36 ATP total. Actually, I probably shouldn't have written that there. 32 of which we will get in the electron transport chain, and the electron transport chain is the place that water is used, and it is used, it's the place that oxygen is used, and oxygen is used to accept the electrons, and then that oxygen becomes water. So hopefully this has helped you guys, and you'll do awesome on your pre-lab, on all your classwork, and on your eventual lab exam.